These are the notes for Chapter 10, Heat and Heat Technology. We will start with the learning targets for Section 10.1. I can describe how temperature relates to kinetic energy, and I can define and give examples of thermal expansion. Section 10.1 is on temperature. Just a review, temperature is a measure of how fast particles are moving in an object. The faster particles move, the more energy they have. Also remember that thermal energy is all the kinetic energy due to the random motion of particles that make up the object. Remember, we said faster moving particles have more kinetic energy and more thermal energy. Hot and cold are terms that can be confusing. They're very subjective. What may be hot or cold to one person is not to another. All matter is made up of atoms or molecules that are in constant motion. We discussed this before in Chapter 2. More motion means more kinetic energy, and more kinetic energy means higher temperatures. How do we measure the temperature? Common ways that you might measure temperature is to taste it, like a cup of coffee, with your finger measuring the temperature of a bath water, or with a thermometer. Thermal expansion is the increase in volume of a substance because of increase in temperature. Particles move faster and spread out or expand. You can see that in the picture below. As the blue dots expand, they get further apart. A thermometer works on this principle. Temperature conversions. In American, we use Fahrenheit, and water freezes at 32 degrees Fahrenheit. Scientists use Celsius, and water freezes at 0 degrees Celsius. And the SI unit for temperature is Kelvin, and water freezes at 273 Kelvin. Below you can see the thermometers, the conversion rates for Kelvin, Celsius, and Fahrenheit, and also the table on the right shows conversion formulas if you want to change one temperature to another. Absolute zero is the lowest temperature on the Kelvin scale. At this temperature, all molecular movement stops. This temperature has never been reached, but scientists have come close. If you think about it, this makes sense. We say that the particles of an object are constantly in motion. We're never going to be able to have them completely stopped or reach absolute zero. Some other uses of thermal expansion would be expansion joints for a bridge that allows the bridge to expand and contract during hot and cold temperatures. Bimetallic strip, which is two different metals that are stacked into a thin strip, and they're used in thermostats. The center picture below shows a bimetallic strip and the principle of it changing or contracting and expanding based on temperature. The final example would be in hot air balloons, and if you remember, hot air rises.